All righty, and I believe we are live. Excellent. So, welcome back to the game of programming. Um, in case you aren't aware, last week I kicked it off with session zero, where I gave kind of an introduction. And the overall goal of this is to give you a way to think about programming without worrying about code, and instead using the language of games to give you the mental models you need in order to uh, create software effectively. And I think this is going to be really important as we move forward. We've seen a rise in things like vibe coding. I'm beginning to see this take off in ARG's alternate reality games, which I think are super cool. But there are a few key points when you're building games that determine whether or not they're going to be successful. And as it turns out, we can use a lot of these same ideas when it comes to thinking about software development and games and everything like that. So, all that being said, let's go ahead and get into it. So, last week we introduced a lens for looking at systems. We started with rules, and then we talked about how those rules allow different types of changes, and then those changes can be observed by the players. Okay, so today we're going to break something that feels incredibly obvious. We're going to break the idea that systems run in time. Think about that for a minute. Naturally, you think about a system and you think about stuff it does, it happens inside of time, right? I'm going to argue that that's an incorrect framing. So let's take it seriously and give it a bit of a test, huh? Okay. So we think about systems in terms of running in time. You know, software runs inside of time, games run in time, life runs in time. And this feels obvious, so we just don't question it. But when something feels obvious, it's usually because we're skipping a step. There's something that we're missing. So instead of, thinking about time as where the system runs, let's actually look at a slightly different framing for it. So instead of saying that systems run in time, let's say that systems run in change. Now, this is actually a very, very powerful framing because it's not about how long something takes, it's about what changes happen. And when an observer um, is able to observe these different changes. And so, with this reframing, time then is something an observer infers after noticing what changed and when. If that sounds too abstract, that's fine. We're not going to argue for it, but we are going to work on experiencing it. Okay. So again, systems run in time, right? Feels obvious, but we're going to modify that. We're going to adjust it to say that they don't run in time, they run in change, and then time is what observers infer. So let's recall the lens through which we looked at games. A game is a set of rules that determine what changes can occur and who can observe those different changes. Notice what's not on here. There's no time, but there are changes. So let's take a look at a little more concrete of an example. We're going to look at chess. And specifically, we're going to look at two different types of chess: blitz chess and correspondence chess. Same rules, same board, same pieces, same allowed moves. Is it the same game? Mechanically? Absolutely. 100% the same game. Experientially? Absolutely not. They're two very, very different games. So why does time feel completely different? Nothing about the rules changed. What changed was the feedback loop. So nothing about the game changed except for the feedback loop of when the move happened, when you notice, and when you're able to take the next move. In blitz chess, every move immediately creates pressure. In correspondence chess, the same move can sit for hours or days. The clock didn't create the feeling. The timing of visible changes did. Time didn't change. What changed was how often you noticed something was happening. Okay, now let's take a look at a slightly different example. We're going to look at idle games, games where you barely do anything. Very little actual change. And yet, there's an incredibly strong feeling of progress. So, why does waiting feel productive? Waiting feels productive because change is visible. Even tiny changes, if they're observable, create a sense of motion. Okay, let's look at something a little different now. Now we can look at turn-based games versus real-time games. Turns feel slower, but they're often more satisfying. Why? Because turns create clear boundaries of change. They tell you something just happened, now you can respond. If we look at real-time games, they're continuous, they're ambiguous. A lot of times there's not a clear sense of when you should act, and so it's kind of everybody just acting all the time. So turns aren't about time. They're about when change becomes legible. So this gives us a very important distinction, and that's the distinction between observable change and latent change. It's all about what changes the player is aware of. Observable changes you can see. Latent changes happen inside the system but isn't visible to you. If a system is changing constantly, but you can't see it, how does it feel? Usually it feels slow or broken or unfair. When you can't see the changes that are occurring, you don't know how to react because you don't know what's changed and what hasn't. This is why UX matters so much. And UX in this, it's a shortening for user experience, in case that's something that you're not familiar with. So a loading spinner and a progress bar might represent the same work. But let's think about it in terms of observable versus latent change. A loading spinner tells you something is happening. It'll take a little bit. What's happening? Don't know. That's not the job of a loading spinner. Loading spinner is only telling you something's going on. A progress bar, though, a progress bar says, hey, there's work going on behind the scenes, and you can see how far along it is. UX doesn't make systems faster, it makes change observable. This gives us the absolute core question of system design. We're going to use this the rest of the course. What changed and for whom? This two-part question can give you any answer you need. This question explains bugs, it explains latency, it explains UX problems, it explains distributed systems engineering, and it explains why AI tools sometimes feel unpredictable. What changed and for whom? Now, here's an exercise that I want you to try. I want you to design or imagine a simple game. And I want you to play it under two sets of rules. First one, every move is announced. So you get to see the inputs. The next time, try it with only outcomes being announced. Nothing else changes. One version, you see the inputs. The other one, you see the outputs. And then I want you to ask yourself, which version felt slower? Which felt fairer? And which made you more anxious? With this game, you didn't change time, you changed visibility. So again, what version felt slower? Which felt fairer? And when did time feel like it was passing? Okay, want to name some concepts here. These words, latency, feedback loop, turn, tick, are just names for the things you've already felt today. You don't need to memorize the terms, but you do need to notice them. Today's takeaway is simple. Systems don't run in time, they run in change. And then time is what observers infer from what they notice. If we connect this to software now, we're talking about games, there are things like API calls, calling out to a different system, a system that you may or may not have ownership over, a system that you can't see what changes are occurring inside of it. All you see is what you send out and what you get back. A spinner shows us something is happening, right? But we don't necessarily know what. We change that to a progress bar, maybe we have a little more insight. Notifications. Got to keep you updated on those changes, right? Now, do those notifications actually map to changes that you care about? Probably not, if I had to guess. Mostly people designing this stuff just want your attention because they can't see the changes that you don't make. That's a really important thing, too. We've been talking about this from the point of systems, and we don't often think about the people designing the systems and what their limited visibility is. A lot of these systems are incredibly complex and have hundreds or thousands of people building them. People are doing the best they can with the tools that they know how to use. But there's this lag in who can see what and when. And then there's the idea of a background job, something that, you know, runs behind the scenes so you don't have to worry about it. But you can't see it. And so software feels slow when change is hidden. So why does this matter? It matters because predictable systems feel fast even when they aren't. Let's say that again. Predictable systems feel fast even when they aren't. Next week, we're going to push this a little further. We're going to look at the same system with different observers. We're going to look at players as observers. And so, what I want you to take away from this, I want you to pay attention this week to the changes you notice and the changes you don't, particularly the changes that you don't notice that you would expect to notice. One of the things that I found in this AI driven world everybody is moving so quickly, they don't even think about how the changes are being observed because the people building the software are moving much faster than the people using the software. But the people using the software feel like they're moving fast because, again, predictable systems feel fast. When you put out a tweet, there's a chance that somebody might respond. The changes aren't predictable. Maybe you get a like, maybe you get a comment, maybe you get a quote tweet and are subject to a flame war. Who knows? That's not predictable. And so it feels very slow. It's not predictable, so it's hard to learn. If we contrast this to an AI system, when I type a message into ChatGPT and I hit enter, I can predict that I'm going to get a response within a few seconds. But how fast did I move in a conversation on ChatGPT versus a conversation on Twitter? Well, it depends on who I had that conversation with on Twitter. If I have a conversation with somebody who really knows their shit, maybe I move faster than I do in ChatGPT. But when I can't guarantee that I get that response, I'm going to default to ChatGPT because it feels faster. One of the things that we have to realize is people end up moving toward predictable systems because they feel fast. But then the trick is, are they really fast? Or do they just feel fast? There's some discussion right now around programmers using AI to code. And what initial studies have shown is that programmers feel like they're moving faster. But when you look at the actual amount of work being done over time, it's not actually faster. And this comes down to how our brains work, because when we can type in a little bit and get this guaranteed outcome, that feels like it's fast, but it's really hard to evaluate the systems that are less predictable. This becomes very, very important when we're thinking about how AI systems work, because it's really easy to get a system that feels fast and breaks everything because it doesn't actually work, but it's predictable enough to the people observing it. The players, as we'll talk about next week. And so, how do you create systems that feel slower but can still win? It's a tough problem to solve. But it turns out you can do it when the predictable part is the fun. There's a saying I go back to, and it's from the creator of Exploding Kittens. And he was on a podcast giving an interview, and he said, the job of a game is not to be fun. That feels wrong, doesn't it? Aren't games supposed to be fun? According to the creator of Exploding Kittens, no. The game's job is not to be fun. The game's job is to make the players fun. This is the most important thing to remember. Fun beats fast because fun is a state that you want to stay in. You only move fast when you're trying to get through something. And I think that's where we're going to leave it for today. Again, next week, oh, there we go. So next week, again, we're going to look at same system with different observers, players as observers. Heck, systems don't run in time, they run in change. And we're going to end with a blank slide. What changes do you think you're going to see next week? I don't know. Drop a comment. Let me know. If any of this was helpful, please, feedback is appreciated. I'm doing a live stream because I think it's a great way to potentially get live feedback. But I don't have enough of an audience to guarantee live feedback. And so I'm recording it uh, in hopes that, you know, people are able to get value out of this. And then I can package it together in something that is effective for people to understand how these different concepts play together. And so appreciate any feedback you have because if it changes something in your life, I can't see it unless you tell me. Um, so please let me know. Thanks for watching.